Our next speaker is Claudio Cacciari from SURF, and his talk is entitled iRODS as Backend in a Data Transfer and Exchange Application.
Hello, good afternoon. I'm Claudio from the Data Management Service team at SURF. SURF, most of you know it, but it's a consortium that supports the research in Netherlands, providing data and computing infrastructure. Today, I'm going to show you how we have connected iRODS to an application for the data transfer and exchange. The application is called Neptune and has been developed by us. Development is still ongoing, but we have already reached let's say, a good state. The tool orchestrates data transfer between different data provider, connection protocol, authentication mechanism, users. So the objective is to address the problem of fragmentation. Fragmentation in terms of having heterogeneity in the infrastructure with different services, so technically, but also from the organizational point of view, when you have users belonging to different organizations with different authorization that need to exchange data. The challenge, of course, is to keep this tool simple enough to allow researchers that are not IT experts, of course, to use this. So that's our current challenge. So what is it? It's provide an API which try to model a generic data infrastructure. So let's imagine a hub for cargo ship. You have many different ships in model and size. Every ship can dock, and the hub take care of automatically transfer container from between one ship and the other, or the ship and a train and truck. So take care of the logistic basket. This automation is what we call orchestration. This is about the technical part, but as I said, we want to address also the user, the people, and in particular, giving researcher an easy way to transfer data between different systems, because we know this current pain point, let's say, for many research, in many projects. And an easy way also to request and share data. Again, this is already, you may think you have already seen this functionality. Yes, we already are aware that many platforms already offer this. But the point of this application is to do cross-platform. So as far as everything happened within the same platform, of course, there are already many tools doing this. We don't need to reinvent the wheel. But we see a gap when we need to go on top of it. So between different data provider, different application or ecosystem. And of course, we don't want to forget the administrators that also are often tasked in connecting different systems and automating workflow for the researcher, and having an API that already create a building block for this kind of workflow, of course, make easier their work. And the same for the developers. Developers, when you need to integrate different systems, are often asked to reinvent a lot of things that are already available in terms of authentication, orchestration, and so on. So iRODS. iRODS is one of the what I call data provider in the system. So we have used FSS Patch library, which is a Python community-based open source project to connect iRODS. It was already existing an implementation of file system specification, that's FSS Patch in Python, but was old and not working with the latest version of iRODS and the iRODS Python client and so on. So we have kind of refreshed it, called it FSS Patch 2, and is available online, open source. So if you are curious, you can look at it. And the same for the Square code. We have tested with iRODS 5.0.2 and Python iRODS Client 3.3.0. We use this in both the server and the client. In the client side, it's used for upload, download of data, while in the server, it's stream data from iRODS to somewhere else or from somewhere else to iRODS. And compared to, let's say, the most basic functionality of the file system patch library, which are an abstraction of a file system, so allow to list, copy, move, rename, like the basic Unix, let's say, command on file. We have added this feature, so you can have automatic registration in the registry of FSPatch. You can pass ticket. The iRODS ticket is supported for authentication. The iRODS session management can be implicit or explicit. Both are supported. We have tested with various parallel connection to iRODS, and we see that was sometimes, let's say, the application Neptune was able to overload iRODS with a lot of parallel connections. So we try to mitigate this, adding a mechanism that have a maximum of 32 concurrency session per process, and a retry logic mechanism, which, let's say, in some cases make it a bit more stable because it has a backoff of 2 for 8 seconds to retry in case of failure due to a very temporary network hiccups or things like that. And now let me show you the application, which is this. So now I will log in with my user. This application is running remotely on Surf Cloud, and I'm just connecting to the web portal. The application presents you as a main interface, a list of the provider, as I call it, data provider, this small disk here. And you can just list the data within them. For the people familiar with Surf Service, we recognize a research drive, a web DAV based on Nextcloud. Surf Drive, another Nextcloud instance, we have web DAV. Snellius is a HPC cluster. Spider is another cluster. Lighthouse is an iRODS system, iRODS 5 system. So how my user has access to this? Because my user can connect to a list of predefined services that are defined by the admin of Neptune, not by the user, but the user can select one and try to connect. So let's say that I want to connect to Yoda. Now I have created some temporary credentials, so I can show you to this Yoda instance. This is a test environment, again, hosted at Surf. And connecting Yoda, in this case, again, meaning connecting to iRODS. So yeah, I'm connected and I can list the content. But the point is not just listing, but transferring. So I have possibility to go here, and I have the interface to transfer data between two services where my user, has an account. So I have already an account there, and I can select, let's say, iRODS, Lighthouse. I am listing my home in iRODS, and let's say that I want to copy one file of 100 megabytes. And I want to copy it on my home on a computing cluster. This is Snellius. Now I can select this folder, which is my home, and say, start the transfer. Now the transfer is not synchronous. There is an asynchronous agent that pick up my request of transfer behind the scene, and then will stream the data between the two systems. So while this is ongoing, let me show the other option that I have. So I can be another user, in this case, Poseidon. You see here, that is a different user. This is, again, another user on the same iRODS system, iRODS. So this user wants to share data with me. And I can share data between two users from iRODS. So iRODS is here. I select Paris. and I say, okay, direct access. And then with everyone connected, every user registered, and I say, okay, share. And now I have shared Paris. Now let me see my other user. Yeah, this is Claudio. Okay, the transfer meanwhile is completed, successful, because if it is failed, you see this symbol here with information about the failure. And I can list the data shared with me, and now I have Paris. And I can transfer the data. Notice that I don't see any credential from the other user. User does not need to share with me an access token or whatever. It's everything behind Neptune. The user only see, oh, I have a link shared by someone else. And then I select the service. Let's say, again, Snell use maybe, or I don't have, yeah. And then I say, okay, copy Paris there. And again, I'm copying, in this case, Paris. But I can also try to share something without explicitly giving direct access. I want the user only let the other user know that I have certain data, but I want an explicit request. For example, I can share, new data share, again from iRODS, this time Squirrel. And this time I click required approval. I share, and in this case, the other user, Claudio, see that Squirrel, but there is no link transfer. There is a link request access. So I can only go here and say, oh, I like Squirrel. And say, please, let me download this picture. And now I see it's pending because Poseidon has a list of requests and say, oh, Claudio has requested this data that I shared with him. So review and say, okay, I like them too. Approve. So now Claudio should see, if I refresh, yeah, the request has been approved. And now I can transfer the data. Squirrel is here. I can put it on, I don't know, maybe Surf Yoda. Let me see if I find a folder where I can write. This one probably. Yeah, this one, this folder. Start transfer. Okay, now it's a transfer between an iRODS system and a Yoda system, which are not federated in this case. Okay. The other option that I have is to share with a public link. So far, what I have shared is someone link connected, registered in Neptune and login. But what if I share with someone outside that has no account on Neptune? So I can do a new share from Lighthouse, from iRODS, and share this file, a PDF, and say download link, upload and generate link, because now I'm connected to a file sender application. I am behind the scene. I'm coordinating a workflow with an application called a file sender. It's an open source project. Surf hosted one instance of it, and is allowed to upload data and share with others via a link or email. That's the point. So now if I go in the data that I share with the others, you see I have a download link. It's an asynchronous operation, so it can take some minutes. But what you get is a copy link like this in the end. And I have done already before the presentation to make things quicker. No, not this Windows. Here. Yeah, this is the link. So you can now download directly from iRODS if you want. Okay, just to clarify what you have seen, my last few minutes, I have, where is it? Here, my presentation. Here. Oh, can I move this? Yeah, this is what you have seen. So a web interface connecting to API, storing transaction of the transfer and sharing request in a database, MongoDB in this case, all the secrets shared and stuff staying in a vault, encrypted, HashiCorp vault in this case, and then adding an agent, Triton, which is the one really streaming the data between two services. One was iRODS or Snellius, a computing cluster, or Yoda, and so on. You can have multiple agents, of course, but that's just a simplification. And as I said, Triton, the agent, collect data, authenticate, decrypt the credential, execute the copy as mechanism of failover to retry multiple times the copy fails, and so on. You report the progress. If for long copies, multiple files in a folder, you can track, and also update provenance records. So you always record in the database who has copied what, who has requested when, so everything is tracked. And there is also search backend. This is not implemented yet in the web interface, so you don't see any search bar there, but it's in the API. So that's the next step we are going to implement. But in the API is already there, and iRODS is also here. So we are using, again, Python iRODS client engine query to search, to scan the user space in iRODS of a user, because you have seen me listing the file in the web interface to select a file and transfer, which works fine for a few small data set, but imagine you have millions, then you need a tool to really scan and search a lot. The result of a search become a virtual collection. So you can already manipulate it as a collection in the Neptune server, saying copy all the results of the research or share all the results of the research. That's a team behind it, my team and another two, Malu and Simone, that are part of the web front-end development. And this is the source, GitLab source project.
Great. All right. Do we have any questions? We got one right here. Do we got a mic?
Maybe not. Oh, there it is.
Okay, there we go.
This is great. This is the first time I've seen it. I think I'd seen links to this before, but not seen it in action. I think I missed at the beginning. Who is in charge of giving accounts that can talk to everything? How does...
So we manage, the administrator of Neptune, in this case us, manage the account for login to Neptune. The first action that I did.
The top level, yeah.
Can be username, password, or at the moment we support also OEDC OAuth2, so you can connect to an identity provider. But then it's a user that decides, oh, I want to connect. There is the user has a list of service available in the system, a fixed list.
Which are provided by the administrators of
Yes,
Neptune. Okay.
the administrator and trust some service, register in the system and say, okay, pick one. User can select one, multiple. A user the assumption is that the user has already an account on separately from this system.
I see. That was what I missed.
Yes.
Okay.
You can log into a Snellius computing cluster, a Yoda provider, an iRODS system. This is independent. So user in some way need to have already an account there and can say, okay, Neptune connect to this service on my behalf and orchestrate all these data.
Yeah, so there's no proxying. These are the users doing the work. They already have access to these other systems.
When you see me connect, Neptune is trying to reach the system with the user credential, validate, yes, you are really
it was live.
Valid, and then coming back.
Very good. Thank you.
All right. Any other questions? Oh, got one over here.
Thank you for the presentation. Something that it was not clear for me. So the sharing is user to user, or you can just share, like, leave open certain data sets such that users of a certain platform can just search over them of what is available, for instance, based on metadata.
I'm not sure if I understood, but yeah, you can share with another user or another group of user or with everyone.
That's okay. Okay, that was not clear for me. And then I can then search over this data that is available for everybody, for instance, using the API.
You have a possibility from the API to list all the data shared with you. A single user can see all the data shared with him. So if there are public data shared with him from everyone, then the user can search through them. Yes.
Based on metadata.
Yes, also based on metadata.
Okay, thank you.
All right, thank you.